Alright, in this video we will look at regressions. So let me find that word here. So a regression is what you do in Desmos whenever you are given a table of values and you have to come up with an equation. Okay, so let me show you how to do that in Desmos. So whenever you see a table in your question, just plug it in Desmos. Okay, so to do that, we're going to press the plus button and then just plug in the values. Make sure that however you're plugging it in, make sure that the x and y coordinates, they match. So one has to go to 225 and so on. Okay, make sure that you enter them in accurately. Once you plug them in, you can then tell Desmos to write an equation. Well, before I do that, how do you know like this is what you're supposed to do? Some keywords that you'll see on your questions are when it says, like for example, it says based on the curve of best fit. Whenever you see this curve of best fit, you know that, okay, well that's what I have to do in Desmos. Okay, so once you have this in Desmos, you don't know if it's a linear regression or a quadratic regression unless you kind of look at the graph or the points and you can guess. You can see on here that it's a pretty straight line, so it will be a linear regression, and the linear regression model, you have to memorize it. Okay, it's not going to be given to you on the SOL, you just have to know how to write it. So the linear regression is y1, so y1 is right there, right? Regression is this little symbol that we have here. You can find that on your keyboard, on your computer, or you can go to functions, not functions, sorry, you can go to your keyboard. Where's your keyboard? Right here? Well, hold on. Where is it? Oh, sorry, yeah, it's here in ABC. That's what it is. And then it's right here, okay? I don't want double, I just want one. But it's probably just easier just to put it on your keyboard. Okay, regressed against A, X, 1 plus B. AX1 plus B. That is your regression. Now, for linear, for quadratic regression, I'll go ahead and type it up for you as well. So quadratic regression is y1. So both of them start off with y1, regressed against ax1 squared plus bx1 plus c. Okay, well, both of them are pretty good regressions for these specific points, but so yeah, but I'll just stick with the linear regression, but these are the ones you have to memorize. Okay, let me take this off. Okay, so what do I need from this information? I need the A and I need the B, because my equation here, my equation is in the form y equals ax plus b, where basically your A is your slope and b is your y-intercept. So here, Desmos tells me that A is equal to negative 19.0, I'll just say 6, negative 19.06, and then B is equal to 243.87, 243.87, okay? So that's my equation right here. It says, let me read the question again. It says, based on the curve of best fit, how many complaints should the company expect at the end of 8 weeks? Okay, at the end of 8 weeks. Well, we're looking at 8 here, and we want to know how many complaints they can expect at the end of 8 weeks. So, let's see. What I'm going to do here is I'm going to put y equals ax plus b. Basically, it copies the same graph down for you. But here, I'll go ahead and change the x. Let me just put a parenthesis around x. And I'll just change the x, which is 8. So it's going to be about 91 complaints. Nope. 91 complaints. Okay, so it's a bunch of steps in here. I hope you're practicing this skill, and let me know if you have any questions. All right, next one. So it says here the table below shows the height. So again, honestly, when I see a table, I'm going to plug it in Desmos. So I'm going to start over. This is also really important. If you already have a table, don't do another new table, because then this changes to a 2 and it just gets confusing. Just clear the whole Desmos. And then go ahead and plug in your table. So you have 0, 1, 2, 3, and so let me pause the video. So I don't see the points. I always start with like pressing the plus button and then kind of trying to find it. Okay, so on this regression, you kind of see the trend here. The points are going up and then they're coming back down. So when you see that type of a pattern, that's when you know it's going to be a quadratic regression. Also, if I look at my answer choices, most of them are also quadratic. Okay, if this was also quadratic, then I would know for sure quadratic. But anyway, you see that the points, they're going up and then coming back down, so that's a quadratic. So I'll type the quadratic regression, bx1 plus c, and then there you go. So it's just asking me to what the equation is going to be. So it's going to be in the form ax squared plus bx plus c. It could be these two. You just want to find if the a matches with what I have in Desmos, if b matches with what I have in Desmos, and then this is c. So a is at negative 25, b is at 3175, and then c is at, it's rounded, but yeah, that is definitely the one. Okay, if you want to be sure, you can definitely just plug in your answer choices and see which one matches. But I mean, at this point, you can just do this. Okay. Also, yeah, I mean, I guess if I didn't really have to do the regression either, I can just have put the answer choices in. But in case you don't have an answer choice given, you can see which one is best. Okay. Right. That's that. All right, next one. Using a graphing calculator, so same thing, same thing, same thing. This one I have to use the equation, and then, yeah. Okay, guys, so I'll go ahead and finish this video. I'll do the rest of the problems. If you want to stop the video here and then move on to the next one, you're more than welcome to. So I'm just going to go through each of these examples, okay? All right, so I'm going to go ahead and plug this in Desmos right here. -4, -1, oh. Two, 3, 5, 8, 10, 12. So you can see kind of a quadratic here, because see how the trend is going down and then it's going back up, the shape turns. So that's how you know it's a quadratic. So I'll just do the quadratic regression again. Okay, well, first of all, if you go to the SOL and then you don't remember this quadratic regression, and you're like, what do I do? Well, how about, since this is a multiple choice, how about we just try plugging in the answer choice and see maybe if we can find the answer that way, okay? So I'm just plugging in the answer choices to see which graph best represented. This graph is pretty good, right? It's going through a lot of the points, but when you're doing this method, you want to type everything in and see which one is the best one. I don't know. They both look pretty good. So, and those are my only two quadratics. So which one am I going to choose? I don't know, you guys. I have to do the regression to be for sure. So I'm going to do y1 regressed against ax1 squared plus bx1 plus c. Yeah, it's going to be the first one. It's going to be A. All right, let me do the next one. So for the next one, I see that I have coordinates. I'll put them in Desmos using a table. So this is just saying -4 goes to -4.8 and so on. Okay, so that's how you would put the coordinates in Desmos. Okay. All right, and then I'm just gonna find it. That definitely looks like a quadratic, right? So you're gonna do the quadratic regression, because I do not feel like typing all the answer choices in, but you can if you'd like. All right, so that's 1.5, 4.2, and -4.9. There you go, SB. All right, bicycle speed. Okay, I see a table. I'm just going to plug it in. I'm just going to plug it in at this point. Boom, boom, boom. So I just have different examples here and what the tables might look like on the SOL, so you know how to exactly put it in Desmos. Okay. $15 goes to 55, and then $17 goes to 63. All right, that definitely looks linear to me, even though it's linear. So I'm going to go ahead and put the linear regression. It's 1 plus b. And then it says here, using the equation of the curve of best fit, which best predicts the skid mark if the speed is at 32 miles per hour. Okay, so when the speed is at 32, what would that be? So basically what you're doing here is you have your equation, which is y equals a, which is 4.06x, plus b, which is -6.22. And then what it's asking you to do is take the equation that you just found in Desmos, and then you are plugging in the value that you're looking for. In this case, for x, I'm looking at 32. So that's what I'm plugging in here, and then I'm going to calculate that. Either you can just retype everything, or if you want to use the a and b, I mean, look, it just copies the same numbers for you. So this is the way I would do it. So y equals a times 32. Since a is right here and Desmos will copy it for you, we'll use that specific a. I would do it this way. So it's at 123 or 124. Okay. All right, last one. All right, I put the table in, and I think this is a quadratic. I kind of see it, maybe the trend going down and then maybe going up. I'll go ahead and do a quadratic. But then I look on my answer choices, I don't see any quadratic because I don't see a square. So never mind, I'll do a linear then. So this is y1 regressed against ax1 plus b. And it's going to be negative 0.12 and then plus 35. Yeah, this one. All right, guys. Thank you.